Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about organic reaction and mechanisms. So first, what is the meaning of substrate? You know, in a chemical reaction, the reactant molecule undergoing attack is referred to as the substrate. The second important term, reagent. General term used to describe the attacking species is the reagent. The substrate and the reagent interact to yield the product of the reaction. Now, the carbon bond in the substrate molecules are broken to give fragments which are very reactive and constitute transitionary intermediates. The steps of an organic reaction showing the making and breaking of new bonds of carbon atom in the substrate and leading to the formation of the final product through transitory intermediate are often referred to as its mechanisms. Friend, organic reactions and mechanism, the factor which influence the reactions: inductive effect, minus or plus effect, I effect, or mesomeric or resonance effect, M effect. Now, what is inductive effect? Inductive effect, it is the polarity produced in a molecule as a result of higher electronegativity of one atom compared to another. It involves sigma bond. The sigma bond electrons which form a covalent bond are seldom shared equally between two atoms. This is because different atoms have different electronegativity values and different power of attracting electron in the bond. So electrons are displaced toward the more electronegative atom, and this introduces a certain degree of polarity in the bond. The more electronegative atom acquires a small negative charge and less electronegative atom acquires a small positive charge. So you can see in this example, CH3OH, oxygen have positive charge, and another example, methyl chloride, carbon have positive charge. Now, organic reactions and mechanism. Inductive effect, the carbon hydrogen bond is used as a standard, zero effect is assumed in this case. So plus I effect, atom or group which lose electrons toward a carbon atom, electron releasing or donating, example CH3, CH2R, CHR2, etc. Minus I effect, atoms or group which draw electrons away from a carbon atom, electron withdrawing, example NH2, NO2, CN, OH, SH, C6H5, CH. So an inductive effect is transmitted along a chain of carbon atom, although it tends to be insignificant beyond the second bond. So you can see here the minus I effect. So carbocation stability, you can see the tertiary cation and secondary cation and primary cation and methyl cation, and stability order 3 degree, 2 degree and 1 degree, and then methyl. Now, organic reactions and mechanisms. Factor which influence the reaction like mesomeric or M effect. It is polarity produced in the molecule as a result of interaction between two pi bonds or a pi bonds and lone pair of electrons, and this effect is transmitted along a chain in a similar way as our inductive effect. So you can see in this example all transretinals and formations of the oxygen negative charge, carbon positive charge. Now, organic reactions and mechanisms. Mesomeric and or resonance effect. In carbonyl group, the oxygen atom is more electronegative than carbon atom. As a result, the pi electrons of carbon oxygen bond, double bonds, get displaced toward the oxygen atom. Now, factor which influence the reaction like the resonance effect or M effect, plus M effect, atom which lose electron toward a carbon atom, example NH2, OH and SH. Activating group or ortho-para-directing, exception halogens are weak ortho-para-directing and also ring deactivators. Now you can see the minus M effect. Atoms or group which draw electrons away from carbon atom, example NO2, CN, CHO, CWS, SO3H, deactivating group or meta-directing. Now bond fusion, you know homolytic fusions and heterolytic fusion. Homolytic fusion, A radical and B radical formation, electrically neutral, have one unpaired electron, extremely reactive, and reaction which proceed via free radical formations. Now bond fusion through heterolytic fusions, you can see the formation of cation and anion. Now reaction intermediate, formation of carbonium ion or carbocation. You can see the organic ion which contains a positively charged carbon, that is the carbocation. Now reaction intermediate. Carbonium ion are named after the parent alkyl groups and adding the word carbonium ion. The stability of carbonium ion is influenced by the resonance effect. You can see this allyl system and benzyl system showing the resonance. Organic reaction and mechanism. You can see the reaction intermediate, inductive effect, tert-butyl carbonium, isopropyl carbonium ion, ethyl carbonium ion, and methyl carbonium ion, and increasing stability. Now carbon ion, organic ion which contains a negative charged carbon atom are called carbon ion. They are also formed by heterolytic fusion. So carbon ion, you can see carbon ion named after the parent alkyl groups and adding the word carbon ion. The stability of carbon ion is also influenced by resonance effect. The benzyl carbon ion is more stable than propyl carbon ion. Now you can see the order of increasing stability. Now organic reactions and mechanisms, carbon free radicals. So they have no charge, they are formed by homolytic fusions. So this is the order of increasing stability of carbon free radicals. Now reaction intermediate like carbene. Carbene are neutral species having carbon atom with 2 bonds and 2 electrons. Now for example methylene, 2 bonds and 2 electrons. Carbene are highly reactive. They act as a strong electrophile because they can accept a pair of electrons to complete their outer shell. Now classification reagent, electrophile. What is the meaning of electrophile? Reagent which can accept an electron pair. In a reaction, electrophile means electron loving, they are electron deficient, attack the regions of high electron density, negative center in the substrate molecules. They may be positive ions or neutral molecules. You can see here the typical electrophile. Now nucleophile, reagent which can donate an electron pair in a reaction. Nucleophile means nucleus loving. They have electron rich, attack the regions of low electron density, positive center in the substrate molecule. And they may be negative ions or neutral molecules. Energy requirement of the organic reactions. Activation energy